Good day, everybody. Or maybe a not so good day. I just found out thermoelectric plants waste a lot of water. They generate electricity by letting steam rotate large turbines, creating electrical power. This steam is then condensed by using larger amounts of cool water, evaporating most of it through a cooling tower. This process wastes a lot of clean water, and companies have to spend more for refilling. Meshes have already been made with the goal of collecting the water vapor, but they only have 1 to 2% efficiency. One research group from MIT won $100,000 in a competition for creating a simple but cost-effective and very efficient water collecting system. By zapping the water droplets with electrons, the charged particles will be attracted to a wire mesh where they are condensed. One of the reasons for this low efficiency is streamline deviation. Simply, the water droplets would just move around the wires instead of hitting the mesh. Their experiment setup of the improved fog collection system is as shown on the upper left. The collected water is coming from a fog generator and is collected in a beaker via gravity. The research, headed by Maher Damak and Kripa Varanasi, describes three main areas for the new fog collection system. Near the ion emitter, a high voltage causes a corona discharge which ionizes the air and water droplets. In the middle of the ion emitter and the wire mesh, the other particles get charged via dielectrophoresis, and the electric force accelerates them towards the mesh. Near the wire, the charged droplets get attracted to the mesh, which is grounded, condensing the water and discharging them of extra electrons. The limit to the voltage that can be applied to the water droplets is based on the drag force these droplets experience. The bottom two graphs show a comparison of separation efficiency and mass of collected water versus K sub E, which is proportional to voltage. Eta D is measured by the formula given. A sub W is the area of the water droplets that will hit the surface of the mesh, while A sub O is the area of the mesh directly facing the water droplets. Data shows that the mesh that can capture the most amount of liquid is mesh 2, having the second smallest opening size. This is due to higher aerodynamic efficiency. The deposition efficiency also has values above 1 because even the droplets that are not directed towards the wire mesh will get attracted. This innovation is significant because power plants no longer have to refill their condensing water, which they usually get from nearby bodies of fresh water. Some power plants also use these freshwater sources once and return the water back with a higher temperature, affecting aquatic environments. One of the many effects will be the change in the O2 concentration. As temperature increases, O2 solubility decreases, making it difficult for marine animals to respire. Being able to use the same water over and over again in power plants also reduces the amount of water that is needed for cleaning. The research team already has a startup called Infinite Cooling. Not much is in their website except the team's contact details and a way to entice possible clients. There is a patent filed in 2014 for a wire mesh used for water collection from vapor. However, I wasn't able to find a patent for using electric discharge for enhancing the efficiency of the wire mesh. The patent generally describes what makes a good mesh, such as high permeability, low contact angle hysteresis, and many more. The mesh can be hydrophobic or woven, and there is even a suggestion to have more than one layer or create 3D geometries using the mesh. None of these suggestions, though, have had efficiencies near or greater than 1. This technology can be used to clean the smog of Manila and other polluted cities or residential areas in the Philippines. The water can then be purified to remove these harmful oxides present in fog. This can also be implemented in homes with no filtering system for their water, just in case their water sources get dirtied or are used up. For this to work, there would have to be a shock of cold temperature so that water in humid areas can begin to condense. A device to control the direction of the droplets towards the mesh is then needed, such as a bladeless electric fan with an ion emitter present in the middle of that fan. For high-rise applications where oxides are present, a purifier should also be added for collection. In residential areas, this wire mesh must also be collapsible to maintain the integrity and aesthetics of their house. A third application would be the use of this technology to to enhance the dehumidifiers in air conditioning units.